All right, hello and welcome. Today is Friday, the end of the second week of online classes. We got some news to share with you, and then we'll review our quiz that we took yesterday. Oh, it was brutal. It was brutal, but you know what it is? We're gonna learn a lot today. That's what it is, as we do all the time after taking the quiz and the test, of course. Um, I hope you are on top of your homework, your mastering physics assignments. They are due soon. I forget what the actual dates are. Make sure you go to your mastering physics and check the calendar or check the due date. So anyway, we do have some news today to share. A couple of things first. As you may have heard, we're going to go ahead and follow the LAUSD plans of closing the school down until May. So perhaps May the 4th will be with us all as we return to school the first week of May. I will truly understand magnetism after I fail this test. Excellent, AP1 student. So that means that we still have one more week of online school, of course. However, remember, the 3rd, April 3rd, is Cesar Chavez Day for us. So that means there's no school that day, and we start off spring break. We call it a break, more like spring finals review week. The following week, from the 6th through the 10th. So that means starting from April 3rd all the way to April 10th, no school technically, in that it's spring break. But that means no streams. Streams will be the last stream will be April 2nd, right? And then we come back for 3 more weeks of online schooling from the 13th all the way to May 1st. And then after May 1st, hopefully we can finally come back to school. Just gaming streams. Yeah, I might do my first gamer stream today. Why are there 3 viewers? I don't know. This is really sad. Actually, there are more people talking in chat than there are viewers. How is that even possible? So I don't think it updates fast enough, because I see there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 people at least in the chat, and some lurkers in somewhere. Yeah, it takes some time to refresh, I suppose. But anyway, so that's that. So school closed until May. We're going to continue. Now, until the College Board actually decides when the AP tests are, I won't make a date for my final, so I will adjust as soon as that information is out. The College Board is currently taking surveys and stuff from certain teachers, I suppose. I did my survey today. They're asking us various questions, and also asking us when would be a good time to take the AP test. I went ahead and voted for between May 11th to May 22nd. Those 2 weeks are the ideal weeks, I think, because as you move past that time frame, it gets closer and closer towards summer, and we all know how our aptitude decreases as a function of 1 over t squared. As t increases, our ability to care for life decreases as the summer between college and high school comes closer and closer. Just an FYI, I have a 2.5k channel points. Oh, great. I hope the teacher surveys are more accurate than the students' one. I don't know. Anyway. So yeah, now they did plan on, of course it is online. You will get to choose between 2 days, apparently, 2 days that you can take it. So that's really cool. Other information, I have other key information about the test itself. Of course, as you know, the test is only 45 minutes. 45 minutes. However, for you guys, stream over. Redeemed highlight. Wait, what? What is that? Stream Overwatch. Oh, you want me to stream Overwatch? What does this redeemed highlight my message 100 mean? I don't know what that means. Oh, you use points to do what? To highlight your message. Oh, that makes sense. Duh. So you can highlight your message to get more attention by using those points. That's cool. All right. Anyway, what was I saying? something about, oh yeah, the test itself. It is 45 minutes, no multiple choice, all FRQs. So for you guys, it's just 3 FRQs, I'm guessing. That's the most logical thing, because usually the biggest FRQ question that you get is about 15 minutes, and I don't think they're going to extend it beyond that. But remember, you guys are signed up for both mechanics and E&M, so you're taking 2 different tests on 2 different days, or potentially you have a choice. But you're taking 2 45-minute long FRQ stuff, whereas the AP1 kids would only take 1 45-minute long thing. So anyway, it's FRQ, and of course all the content is condensed. We've eliminated a lot of other stuff, and it's basically, honestly, if you just took AP1, you're gonna be fine. Because, for example, it's now the College Board uses different numbering system for their units, of course. Right. So in the College Board website, if you go to the My AP, where you can see the classroom and you can see the units, for mechanics it's 1 through 5. So 1 through 5 means for us is actually units 1 through 4 last semester, and 5 is canceled. Remember, 5 was shim and gravitation. Shim and gravitation has been taken out, so it's everything with kinematics, dynamics, torque, and rotational dynamics, a little bit of UCM and pegmaga and momentum. So energy and momentum, of course. So all the stuff with shim, damping, all the new stuff has been taken out. So it's just more of AP1, I guess. So free 5s for everyone. And then for magnetism, it gets even easier. Check it out. Magnetism is basically the first 2 units, 6 and 7. And so unit 8, which is all of our magnetism stuff, is actually out. We call it E and M, but it's actually just E with some circuits. So all of the magnetic stuff, all of, even circuits with inductors, so RL circuits, RLC, and all that stuff has been taken out. So this is probably going to be the easiest test in the world. We're all going to get 5, so let's get a 100% 5 rate in chat. Hype train, 100% 5s. Yeah. Now to be fair to those students who came before you, in order to get your star, you have to get a 5 in the AP test, and you have to get a 5 on my test. That's the only way it could be fair, right? How are you doing this? Are you going through Streamlabs website? How do you do that? I took down my Streamlabs. Unless you remember my Streamlabs thing or something. Alright, anyway. Whatever. So you have to get 5s on the AP test and my test to get your star. Oh, the Twitch thing? Okay. Save your money. I'm not a gamer streamer yet, unless I want to keep the school stuff as professional. Of course, I chose Twitch strategically to penetrate the market, to teach kids who are into games and stuff, because they're more likely to be into physics and other things, or at least they may get a job in gaming if they know physics of etc. So anyway, it's all part of a master plan to take over the world. Y'all are flexing your cash in points. XD. Yes. All right. So the test is really easy. It's going to be very short, really quick, and I hope that everyone will do well. But let's take a look at our quiz, because we did not do well on that one. Oof is oof. Let's see. Let me pull up some stats first for you stat geeks. Here's some stats. Boom. Oh my goodness. Actually, 54% in E&M. I guess I'll take it. Highest score is 80%. Low score is 10. All right. Oof is right. All right. Starting with, let's start with the first question. Take your notes out. I'm above average. All right. The first question had a bunch of wires that are sending in current. 3 of them going into the page and 1 of them going out. No, I said that wrong. 3 of them going out, 1 of them going in. And they're in the 4 corners of a square. And the one at the top right is going in. And we want to find the total magnetic field here at the center. All right. So let's do some color coding. I'll keep this one blue. Let's use this as black. Let's use this as orange. And then the magnetic field from the other one will be red, rojo. There we go. All right. So basically, you're using right-hand rule 4 times. How is multi-niche FF 160p lol? It's a little difficult to explain. Basically, everybody gonna get 100%. What? All right. Focus. We want to use right-hand rule number 1, the magnetic field around a wire. And you can see how for the first 3, the ones that are coming out, the thumb points out of the board, and the curl of your fingers of your right hand go this way. Let me use blue. This way. So when I am at point P here, okay, we're going to use the tangent vector to this circular arc. So that means that the blue one will give us a magnetic field that way, tangent to the circle. All right, orange. Orange is also another circle going the same way. And if we do the tangent to that circle, we get a vector that goes that way. All right, what about red? Rouge. Red circles around this way, so if I do the tangent vector, it will give us something like this. Whoa, I'm noticing some patterns already. Are you seeing what I'm seeing? Are you seeing this? All right, black, the one that goes inwards. We want the thumb into the board, and then the curl of your fingers go around this way. And so the tangent vector to that curl would be in the same direction as B2. So it's B3. All right, so there you have it. 2 of them cancel each other out, the red one and the blue one. And what's left is the 2 that are pointing upwards to the left. Upwards to the left. Now, how do we find the magnetic field from a wire? Okay, that's just mu naught times I divided by, can someone tell us? I got that one correct for the wrong reasons. Good job. Mu naught I times, well, 2 pi r. R being how far you are from each wire, and we are equal distance from each wire because we're directly at the center, and we are d away, so we'll use d instead of r. 2 pi d. Okay, well, we have 2 of them, so the net would be 2 times that. All right, pi d, yeah, the 2's cancel, blah, blah, blah. But you got to choose the best answer, of course, based on what's given in the multiple choice. All right, so that was easy, I hope. Second one, a charged particle with constant speed enters a uniform magnetic field whose direction is perpendicular to the particle's velocity. The particle will, okay, so we have a v, vector v, and it's entering a region where the magnetic field is perpendicular to the v. We don't know which way, but if it's perpendicular, then we know that the force will be perpendicular, and if you always have a perpendicular force, this is straight up from what we talked about right before taking the quiz, we get a circle. Oh my gosh, we're in UCM. Yes, it's a circular arc. Now, when is it a parabola? When is it a parabola? Well, it's a parabola if the force has the same direction. All right, meaning in an electric field, if I had a charged particle in an electric field, let's say this is E. Let's say we have a positive charge going in with some velocity v. If a positive charge goes into an electric field, okay, it's going to feel a force. As soon as it enters the field, there's a force on it that points downwards. So it starts to change its direction, okay? Now, one infinitesimal time frame later, it might be over here, but notice how the direction of the force does not change. The electric force is still downwards with a velocity vector that is sideways, and so now that it's not 90 degrees, it's going to accelerate the particle in the y-axis, therefore it creates a parabola and not a circular arc. Whereas in the magnetic field, where's our picture? In the magnetic field, let's see, we have x, 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 x. Okay, so a particle is going in with the velocity v. This is a positive charge particle. The force is upwards. Okay, thumb to the right, fingers into the board. The force is upwards. When it gets here, oops, not particularly. When it gets to, I didn't like that. Let's try that again. There we go. When it gets to here, the force is upwards. Okay, if it's upwards, it starts to turn. Okay, now it's over here. But if you do the right-hand rule once again, notice how the force vector is not straight upwards. It is sideways. The force vector actually changes because the force, the magnetic force, will always be 90 degrees to your velocity vector. And this makes it so that it goes in a circle instead of a parabola, because the force is always pointed towards the center, like in UCM. Next question. A straight wire is placed below a compass. Actually, only 62% of you got this one. A wire is below a compass, and we're at the origin. So let's say our wire is on the y-axis. The red thing is the wire. And we would have a compass here. North, south, west, east. There we go. A compass that is above the wire. If I look at it in 3D, imagine this being the wire. Let's use red. Okay. The compass would be placed above it like this. So imagine a circular disc-like compass where currently the north is at the positive y. So north is up here, south is over here, west and east. So now we're looking at it in 3D. Haha, Sword Hero got it. What is speed, my lad? I almost forgot the difference between west and east. We are West Coast, remember? California west, New York east. Never eat soggy waffles, etc., etc. All right, now the current is going upwards in the positive y direction. So now we use right-hand rule number 1 to give our curl. The curl goes this way. Okay, so if the curl is that way, this will force the compass to rotate such that the north is over here where the east was, and the west is over here. Okay, so it'll rotate a little bit to take the orientation of what the magnetic field is at that spot. Okay, so the north will now point towards the east. Stephen Bash just hijacked my laptop. Huh? What do you mean? To figure out where the wire and compass were. Oh, are you doing remote support or something? Don't ever trust remote support. That stuff is fishy, to say the least. If you call like tech support and they're like, oh, let me do some remote support for you, say, nah, no thanks. Just give me the steps and I'll do it myself. Just install this. Yeah. You're a beta tester. No, I actually am using remote support. This is how I'm getting my laptop into one of my screens on my OBS, and my OBS is running for my desktop, of course. So I'm remote supporting my laptop into my desktop. He left me a note on screen that said thank you. Okay. All right. Anyway, that's that. Next one, a proton of mass m. Oh, this one. Oof. We did not do well on this one either. Actually, I mean 62%. Is that good enough? Nah, we want 100%. Proton of mass m and kinetic energy k. So mass m, Ke is equal to k, capital K. Passes undeflected. What does undeflected mean? Well, normally it should deflect in that it experiences a force. If you're going undeflected, that means the net force must be 0. and we have to strategically make the electric and magnetic fields perpendicular to each other, because if it's not perpendicular, then the magnetic force, the magnetic field would not provide a magnetic force on the charged particle. That's above average for the test, indeed. The electric field has magnitude E. The magnitude of the magnetic field is B. This is actually really easy. Really easy. Okay. We want our forces to be equal. We want it to be undeflected, meaning if this was the electric force, F electric, then the magnetic force should cancel it out, like so that the net force is equal to 0. That's what we want. Essentially, the electric force must equal the magnetic force. The electric force is charge times the field. The magnetic force is charge times the velocity times the field. The Q's cancel. Boom, boom. Just like that. So B is just equal to the electric field divided by the velocity. We can get the velocity from the kinetic energy formula. K is equal to 1/2 mass times velocity squared. And so velocity is equal to 2 times K divided by M, and then square root. So B must be equal to the electric field divided by square root of 2K over M. Let's go and invert everything. That was it? Yeah, that was it. B is equal to E times square root of, if I do the inverse, I get M in the numerator, 2K in the denominator. Let's go and put the E inside of the radical. And so we get square root of ME squared over 2K. Yeah, the answers were in parentheses instead of pretty text. That's what the Texas Instrument Company calls it, pretty text. But yeah, I mean, hey, you need to be able to decipher the code because the future is all about programming. So you have to program these physics equations in that format. When the answer is basically blah 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 blah. Focus procrastinator. Trash. What is trash? Please explain. Canvas doesn't support latex. So what's interesting is that where you type your question, the text box, is RTX or no, what is it called? RTF, rich text format, meaning I can do all that in the typing part where the question is asked. However, where I actually write down the answers, it's literally just 8-bit, just like notepad style text. I don't know why they're not the same. There's not RTF on the bottom as well, so it's unfortunate. I started that question with 12 minutes and exited with 8. You spent 4 minutes on QE equals QVB. That is an oof. All right, moving on. Next one. Oh, someone's spamming caps. All right, next one has current going this way, and then it circles around, whoa, this way. But we want to find the magnetic field at this point P. All right, this one's another easy one, but it did trip up a few people, and 43% got this one. It's the average time for a reason. All right, so if the current is going to the left, let's go and use right-hand number 1. Yeah, so it curls around this way. Okay, but if you're over here along the axis, it's just 0. It's 0. Vote 1. Vote 0. Yeah. So, I mean, we talked about how you have magnetic field going this way. If you're some r distance away, you can get the magnetic field equal to mu naught I over 2 pi r, right? So what if you are here? Well, r is 0. Uh-oh. Does that mean it's infinity? No, it's because this equation is ignoring the actual cross product. So this equation ignores cross product. It already assumes that it is perpendicular. It's the perpendicular vector. Assumes the perpendicular tangent, or whatever. You could call it the tangent vector. Let's call it the tangent vector. Tangent vector. No, let's call it the perpendicular. I like that one. Assumes it is perpendicular to the circle. Yeah, we always ignore the cross product of vectors. So since it's the cross product, of course, if you're right here, if you're parallel to it, the cross product is 0. All right, the magnetic field inside a solenoid is B. A solenoid, this is just a simple definition thing. Recall that if you have a solenoid, you have a uniform magnetic field inside, and this thing is only dependent on loops per length. I should do capital L. N being number of loops, length being the length of the actual solenoid. It has nothing to do with radius, so it's still the same. So if you have a bigger solenoid, but the same amount of loops per length, how do I do this? Let's see, 1, 2, 3, 4. 1, 2, 3, 4. So notice how this is still in L, and the number of lengths is still 4. The loops per length density, the loop density is still 4 over L, and therefore it must have the same magnetic field. Now, what's the benefit of having it bigger? Well, you have now a bigger region where your magnetic field is uniform. Okay. Now, when it's uniform, that means anywhere inside, not just the center, anywhere inside of the solenoid has the same magnetic field B. So L is length, not like some random thing. Length of the solenoid. All right, 2 wires carry. Oh, I like this question. This one was fun. 2 wires carry current to the right. The wires are 10 centimeters apart. Boom, boom, and this is 10 centimeters. Okay. Let me use colors. Let's have this one as the blue wire, and this one as the red wire. All right, we want to find where the magnetic field is 0. Basically, the magnetic field from each will have to cancel each other out. Of course, they have different amps or different currents. The top one is 6, the bottom one is only 4. Okay, so this immediately should tell you that in order for these things to cancel, not only do they have to point in opposite directions, okay, but you have to be closer to the 4 amp and further away from the 6 amp. Alright, your grade did not think that was very fun at all. Well, grades don't matter. It's what you learn that counts. Anyway, here's our first one. Let's go and do the blue one first. Let's go ahead and point our thumb to the right. Curl comes out of the page at the top. So circle with dots, dot, 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 dot from the blue. And then it curls around and goes into the board on the bottom side. So if you're anywhere below the blue line, anywhere below the wire, you're going to go in. If you're anywhere above the wire, you're going to go out. But would he say that after the test? Yeah, I don't care about grades. I just care about you getting a 5. Red. Okay, let's try red. So red, again, thumb to the right, fingers come out. So anywhere above red, dot, 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 dot. Anywhere above red would be coming out. Anywhere below red would be going in. Okay, so where could they cancel? Well, if they're all dots, that can't be it. If they're all X's, that can't be it. So it must be somewhere in here. Okay, where we get X's from the blue and dots from the red. Okay, it can't be directly in the middle, because if we're equally apart, then we'll be too weak from the 4 amp. What is the magnetic field? Well, the magnetic field is mu naught I over 2 pi r. This stuff is just constants, so B is proportional to the current over the radius. And we want them to be equal. So 6 amps over R1 must be equal to 4 amps over R2. Okay, so it's a direct, correlation. So if I am 6 centimeters below the blue one, then I am 4 centimeters away from the red one. Right? So this would mean that 6 over 6 must equal 4 over 4, and they do. It both equals 1. Yay! Closer to the one with less current and further away from the one with more current. The next question has current going in opposite directions. The two wires carry blah blah blah. The upper wire carries current to the left. Shocking. Get it? Get it? Shocking. A wireless high five for the dad joke. 6 amps to the left and 4 amps to the right. Blue. And then red. Alright, let's do the same approach. Okay, thumb to the left, that means things go into the board anywhere above blue, and the magnetic field comes out of the board when you're below blue. For the red, okay, thumb to the right, it comes out of the page, if you're above, anywhere above, and it goes into the page anywhere below. Alright, where can we cancel? Well, now we have two options, over here or over here, but the middle does not work. Okay, but if we're too close to the 6 amp, that's definitely not going to work. 3 people left after that dad joke, I suppose. That's sad. So we can't be too close to the 6 amp. We have to be somewhere over here. Okay, now the question is how far? Alright. So same strategy, B is proportional to I over R. So 6 over R1 must equal 4, let's try that again, 4 over R2. Okay, and it turns out, if you are 30 centimeters below the blue one, which means R1 equal to 30, and if you're 30 centimeters below the blue one, the red one is only 20 centimeters, because there's a 10 centimeter gap between them. Why do you call a magnetic guy who skips, oh, you mean what? What do you call a magnetic guy who skips school? Ferris Bueller. Can we ban Alex? Yeah, let's go and ban him for his dad joke. I think I caught that one. So 6 over 30 is equal to 4 over 20. And does it equal? Well, yeah. Let's go and divide by 3. You get 2 over 10, and then 2 over 10, or 1/5 and 1/5. All right, next one is the flux. We threw in a flux question. That should have been super simple. I was hoping. Okay, they even give you the. I mean, this is literally just use the formula for flux. What the flux? The field is coming at an angle, and measured from the normal, it's theta here. No. She didn't get 100 points. She used 100 of her points to highlight her message to ban you. Okay, do you get that now? So she used some of her, life savings to highlight that you are worth banning. Yeah. All right. Anyway, flux is the dot product of B and A, right? The magnetic field is the magnetic field. Now we want the magnetic field that actually goes through this window, and that's just the cosine of the angle. So b cosine theta is what is going through it, and b cosine theta times the area. The area is going to be the in-between region. The picture frame, if you will, and that's just length times width. So it's a square, so b squared minus the inner window a squared, and voila, that's all. Last question was the solenoid with the compass. Now you have a solenoid, pew, 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 pew. The current is going this way. That means it goes up this way, down this way. So if it's curling, you need to grab the wire. Okay, what does this look like? This is hard to see. Imagine this part, the blue part, being on the back side, and the black part being on the front side. Like this. So black, and then blue. Okay, grab the wire, grab this segment here. You'll see that the current is on its way downwards when you're in the front. So grab the wire with your thumb pointing downwards, and that makes your curl pointed to the right. So the magnetic field is going this way, to the right, out of the solenoid. It's going to loop around and go back in. Now, ideal solenoids are ones that have many, many loops really close together, high density, high loops per length, which makes the magnetic field outside of the solenoid essentially zero. But regular solenoids will have some magnetic field going outwards. If you put a compass here, north, south, east, west, okay, the magnetic field goes this way. At this spot, it is pointed left, so the compass will reorient itself so that the north is over here, the south is over here, the west is over here, and the east is over here. Let's try that again. North, south, west, east, there we go. And it will reorient itself. Alright, that was the quiz review. We'll do a couple more induction things. I'm basically just waiting for the College Board to announce an actual date. Based on that date, I can kind of reconstruct our thing. We'll do just very light RL circuit things, just so the multivariable kids actually know what inductors are and what they do. And this is if you're going to go into engineering, you'll eventually have to know it anyway. Other than that, we will shift our focus to just electrostatics and regular circuits. I'm going to focus on the new stuff mostly for review. I'm just going to take a wild guess that Gauss's law is going to be on the AP test this year because there's nothing else. So this is going to be the easiest test you'll ever take. I hope so, and we're all going to pass. So that's the only good news to come out of all of this mess. All right, well, I guess that's it for today. Thank you for watching. Do your problem sets. Oh, no, that's not it for today. The problem sets. Actually, yeah. I don't know if you downloaded it, but check your calendar. It does say do problem set 1 today. Will colleges even look at these scores? Well, I don't know, honestly, but it is the College Board, and the College Board has an agreement with all those colleges that offer, that are part of the program, and these are thousands of colleges, not just one or two. The College Board, the AP company itself, it is a company. They have like a president and all that. Do work with like colleges and universities, so yeah, they're not going to say yes if the colleges and universities are not on board with them. So yeah, all right. I guess that's it. On Monday, I want to go over some of the problem set one questions. There's a really cool one with two circular arcs of angle theta. That one is a classic physics question. So make sure you do that. I think it's number 7 on problem set 1. Yeah, it is number 7 on problem set 1. Go and do that at least. And then we'll move on to some more induction stuff and see if we can build our own motor and generators. All right, until next time, see you later.